right? We have to find the sum of values of all these binomial coefficients. Can the previous result be used? 1 multiplied by NC1, 2 times NC2, etc. Alright, so we have to find this sum. If these are the squares of the binomial coefficients, we have also seen many combinations, right? Like binomial coefficients. Of all the concepts of the chapter binomial theorem, the most important part is about the binomial coefficients. The rest of the concepts of the chapter are very simple. The most significant part is about the binomial coefficients. What are binomial coefficients? Let us take this simple binomial expansion, 1 plus x to the power n. So that is nc0 plus nc1x plus nc2x squared up to ncn x to the power n. These coefficients nc0, nc1, nc2, ncn, these are called binomial coefficients. Simply ncr is a binomial coefficient. We have to write certain conditions satisfied by these binomial coefficients. That's what we're going to do in this class. Alright, so we are already familiar with some results based on this ncr, right? Nevertheless, we will start from the very basics. Okay. This is the most important but simple result which I hope you are already familiar with. NCR is equal to NCn minus R, right? So if you want to prove this, say NCn minus R can be written as n factorial divided by, so this minus this, so that is R factorial multiplied by, so this factorial n minus R factorial, right? So that is same as the formula for NCR, right? So NCR also has the same formula. So NCR is n factorial divided by n minus R factorial, R factorial. So NCn minus R is same as NCR, right? So this result is very important, right? So that means simply if you take some example, okay, so 7C3 is same as, so 7C, 7 minus 3, that is 4. So 7C4, or if you want to write say 9C2, so that can also be written as 9C, 9 minus 2, that is 7. So 9C7 equals 9C2, etc. Right? So that's all. Now, as a particular case, or you can also write the result in a different way. If NCR equals NCS, so NCR equals NCS, then we can say that S can be written as n minus r. So this s is same as n minus r. See, when you say NCR equals NCS, it is obvious result that r can be equal to s, right? That is one possibility. There is another possibility, that is this s equals n minus r. So that means there are two cases here. So either r equals s, r can be equal to s obviously, or this s can be equal to n minus r, or we can say that r plus s equals n. Right? So the same result which is written in a different way. So NCR and NCS are equal, then R and S are related. How are they related? Maybe they are equal, or their sum is equal to this n, right? So this is the first result, which is a very simple result which you are already familiar with. So NCR is same as NCn minus R. Okay. It's given that 11CR is same as 11C 2R minus 1. So like we did already, so NCR equals NCS, then we can say that either R equals S, that is one possibility, or R plus S equals N, right? So here, so 11CR is equal to 11C 2R minus 1. So there are two cases. So one case, so that R can be equal to 2R minus 1. So also we have the other possibility, this sum is equal to this value of n, which is 11 here. So we can get the value of r from this. So r is either 1 or r can be, so 3r equals 12, so r can be equal to 4. So that's all, r is either 1 or 4. Alright, these are the two possible values of r for which, so these two are equal, right? NCR is same as 11CR is same as 11C 2r minus 1. Okay. The next result which you have to remember as a formula is this one. NCR is equal to n by r n minus 1 c r minus 1. See, NCR has a formula. So we know the formula n factorial divided by n minus r factorial. So we can write this n factorial as n multiplied by n minus 1 factorial divided by, so n minus r factorial. This r can be written as r multiplied by r minus 1 factorial. So if you separate this one, n divided by r, so multiplied by n minus 1 factorial divided by n minus r factorial multiplied by r minus 1 factorial, and this is the formula for n minus 1 c r minus 1. So this can be written as n by r multiplied by n minus 1 c r minus 1, because what is the formula for n minus 1 c r minus 1? N minus 1 factorial divided by this minus this. So n minus 1 minus of r minus 1, that is n minus r, and r minus 1 factorial. So that means NCR can be written as n divided by r, alright, multiplied by n minus 1 c r minus 1, right? This is one formula that you have to remember, right? So this is the result that you are supposed to remember. Okay, so if you want to reduce this, for example, if you want to find the value of something like okay, let me take a simple example. So if you want to take 6c3, if you want to find 6c3, you can directly find 6c3. We have the formula. You can also write it as 6 divided by 3 multiplied by, so 1 less than that, so 5c2. So that is this result. Okay, 6 minus 1 is 5, 3 minus 1 is 2. So 6 by 3, 5c2. So that can be further simplified. If you write the value of 5c2, that is okay. Or we can further simplify this, 5 by 2, same formula used again, 5 by 2 multiplied by 4c1. Alright, so that is 4 multiplied by, okay, 5. So that is 20. Not that to find the value of 6c3 we are going to do all this calculation, right? But sometimes it is required. If you have just numbers like this 6c3, you should know the value directly, or you can use this formula to find it. This formula is not required, okay? But this idea is important, okay? In some cases, right, certain type of questions, we have to use this particular formula. So NCR is same as n by r multiplied by n minus 1 c r minus 1. That is one of the results that you have to remember, okay? So here we have to prove that NCR divided by NCR minus 1, that equals n minus r plus 1 divided by r. Alright, so the proof is very simple. So NCR divided by NCR minus 1, we directly have to use the formula of NCR. What is NCR? N factorial divided by n minus r factorial, and then NCR minus 1, okay, the reciprocal of that. So that is, so n factorial divided by, so this is n minus of this one, minus r plus 1 factorial multiplied by r minus 1 factorial. So that's all, we just use the formula for NCR. Now certain terms get cancelled, so n factorial gets cancelled here, and what else? We can write this as 1 divided by n minus r factorial. R factorial can be written as r multiplied by r minus 1 factorial, okay? So we can reduce it, right? R multiplied by r minus 1 factorial. And similarly, this n minus r plus 1 factorial can be written as n minus r plus 1 multiplied by the factorial of 1 less than that. So 1 less than that is n minus r factorial multiplied by this as it is r minus 1 factorial. Alright, so this, okay, this divided by 1, that's all. Now we can cancel this term, so n minus r factorial, n minus r factorial, and similarly r minus 1 factorial can be cancelled. So we will get, so n minus r plus 1, okay, that gets cancelled, so divided by r. So that's all. So this is the value of this one, NCR divided by NCR minus 1. Okay, yes. See, this is not a result, right? It is not a formula for you to remember. But if you remember, in certain type of questions, it may be useful, right? Instead of doing these calculations, we can write this answer directly. This is NCR, and this divided by same n here, but 1 less than that. Okay, so we can directly write this answer, right? If you remember, it will be better, right, for certain calculations. But it is not necessary that you have to remember it as a formula. Just to avoid these calculations, you can remember it as a result. See, for example, if you want to find the value of 10c5 divided by, just an example, so divided by 10c4, isn't it like this? Exactly, NCR divided by NCR minus 1. So if you know this result, we can directly write, so n minus r, so that means, so 10 minus 5 plus 1 divided by 5, okay, so that is equal to, so 6 by 5. So like this we can write directly, or we can do the calculation. See, when there are numbers like 10, 5, 4, we can directly do the calculation. It is not required to use this formula. But sometimes, mostly when variables are used, right, r, n, r minus 1, then if you remember formulae like this, so that will be useful for certain type of calculations. Alright, yes. So this is the result, NCR divided by NCR minus 1 is n minus r plus 1 divided by r. Okay. Let's prove this result. NCR plus NCR plus 1 equals N plus 1 CR plus 1. Alright. So NCR plus NCR plus 1. So that equals, okay, let us simplify this. Let's write the formula for NCR, which is N factorial divided by N minus R factorial plus, similarly we will write the formula for NCR plus 1, which is again N factorial divided by, so this minus this, so N minus R minus 1 factorial multiplied by R plus 1 factorial. So let's simplify this. So we can take out the common factor, N factorial divided by, so from these two we can take out the common factor, which is this is 1 less than that, right? So we can take N minus R minus 1 factorial out, or I will take N minus R factorial only. Okay, if you take N minus R factorial, let's see what happens. Now from R factorial, R plus 1 factorial, so if you take R plus 1 factorial out, see what happens. So we have taken N factorial out, okay, the N minus R factorial is taken out, so that means just R factorial, but we have taken R plus 1 factorial, that means you have to multiply by R plus 1. Alright, R plus 1 divided by R plus 1 factorial, that is 1 by R factorial, that's what is here. Similarly, next one, so we have taken out N minus R factorial, that means you have to multiply here N minus R, okay, N minus R. What if you do the cancellations? If it is N minus R, this is N minus R factorial, but N minus R factorial can be written as N minus R minus 1 factorial into N minus R. N minus R multiplied by N minus R minus 1 factorial. That N minus R gets cancelled. So that's how you get this N minus R minus 1 factorial. Alright, simple factorial calculations. That's it. Now let us simplify this. So this is N factorial divided by N minus R factorial, R plus 1 factorial multiplied by, this is R gets cancelled, N plus 1. Now this N plus 1 multiplied by N factorial, that can be written as N plus 1 factorial divided by, this is R plus 1 factorial, N minus R factorial multiplied by R plus 1 factorial. See, this is what exactly given in the question, right? See, N plus 1 factorial divided by N minus R factorial, R plus 1 factorial. So that can be written as N plus 1 C R plus 1. Is that correct? See, N plus 1 factorial divided by this minus this. What is this minus this? N minus R factorial and then R plus 1 factorial. So that's all. So N plus 1 factorial, N plus 1 C R plus 1, that is NCR plus NCR plus 1. Okay, so two binomial coefficients can be combined and made it into one. So for that, these two values should be equal, right? N and N, these two are equal and these two values are adjacent values, right? So NCR plus NCR plus 1, so that is N plus 1 CR plus 1. Okay, yes, as a particular case, so let us take some example. Okay, so take some example. So what is the value of 9C3 plus 9C4? So that equals, isn't it exactly like this? NCR plus NCR plus 1, one more than this. So that is same as N plus 1, that is 10. And then R plus 1, R plus 1 is the bigger one, right? 4. So 10C4. So 10C4 is the value of this thing. Okay, take another example. 10C4 plus 10C3. So what is this value? Right, so here R is 3, not 4, because NCR, this is NCR plus 1. So whichever is bigger among these two, that you have to write here. So 10 plus 1, 11. So 11C. So R plus 1. So R plus 1 we have to write. So 11C4. Okay, yes. Now, what is the value of NCR plus NCR minus 1? So that equals, it is also of the same type only. See, R minus 1. These two are consecutive values, just like here, R plus 1, right? So adjacent values. Now, N, same value. So we can write it as N plus 1 C what? R minus 1 R, right? So that means whichever is bigger among these two, that you have to write. So R minus 1 R. So we have to write R here. Okay, here R plus 1. So R plus 1 is a bigger value, right? So that is written as the formula. Okay, R plus 1 here. Now here R minus 1. So we have to write R. See, sometimes this is written as the formula. Okay, this is written as the formula. This we can take as the formula. Both are same, right? R minus 1. Then we have to write R here. R plus 1. Then we have to write R plus 1, whichever is bigger, right? So this is one formula. These are just examples. This is how you prove this, alright? But this you should remember as a formula, okay? This is a formula that you have to remember. That is the next formula in our list. NCR plus NCR plus 1 equals N plus 1 CR plus 1, okay? This is like a series, right? We have to find the sum of values of all these binomial coefficients. Can the previous result be used, NCR plus NCR plus 1? Let's see. See, these are the terms 25C10 plus 26C11 plus etc. up to 35C20. So we can add these values, right, one by one. Okay, 25, this 26. Can you add these? So we can use that previous result, that is NCR plus NCR plus 1, only when these n values are equal, right? NCR, next one is NCR plus 1, the next value, R plus 1, consecutive values, but n remains same, 25, 26. So we can't add this. So these two should be equal, only then we can add this. Okay, so for that we have to do some adjustments here. So what can be added with this? Suppose we have a term previously which has the same value 25, but this value is 1 less than that. See, you want a value, n value should be same. So I'll add this value 25C9. Okay, you add this value with this 25C10, and the rest of the terms remain the same, 26C11 etc. Last one is 35C20. We have added one term 25C9, so that should be subtracted, 25C9. So why are we adding this term? So only then these two can be added. Isn't it like NCR plus NCR plus 1? So these two can be added, and then so that is n plus 1. N plus 1 is 26C R plus 1. R plus 1 is 10 here. So 26C10. This can be again added with this term. So plus etc. Okay, same terms here. This 26C10, 26C11 can be again added because NCR plus 1 form. So if you add these two, we will get n plus 1, that is 27C11. That can be added with the next term, which is 27C12. So you can keep adding this. So if you do that, so that is 35C20 minus 25C9. Okay, so this 27C11 can be added with the next term, which is 27C12. So that will become 28C12. So you keep adding this. Finally we will get, if you add the term just before this 35C11, C20, so that will become 35C19. Okay, so because this is 28, see the previous term is 26C11, so then the previous term is 26C10. So same term, but this is 1 less than that. So here also we'll get the same thing, 35C20. So 1 less than that, that means 19. The 35 will remain the same. So 35C20. Okay, and then this is 25C9. So this is 35C19 plus 35C20. Again same formula. So 35 plus 1. So that is 36C19 20. So that means 20 minus 25C9. So that's all. So this is the value of the given expression. Okay, so we have to use the formula NCR plus NCR plus 1, but it is not of that form. Okay, not the same value. So we just need one more term which we introduce here. So you add and subtract the same term. So the rest of the terms can be added using the same formula. Alright, so you keep adding this. Finally we get this answer. Okay. This question is similar to the last question. We have to use the same formula NCR plus NCR plus 1. So what is given here is 10C6, 11C6, 12C6 etc. up to 20C6. Okay, yes. So this value, this is increasing, right? 10, 11, 12. So this is not increasing, unlike the last question. So this is also increasing. These values, R value is also increasing. But here, these are constants. Okay, so we have to do it in a different way. Okay, see, we can make it a increasing sequence. If you write 20C6 as 20C 20 minus 6, which is 14, right? 20C14. So this will become 10C4. 10C6 is same as 10C4. So 10C4, this is 11C5, right? 11C6 is same as 11C. 11 minus 6, that is 5. So this is 12C6. So this is 4, 5, 6. That will become an increasing sequence, just like the last question. Alright, so that can also be done. We can make it like the last question. If you use the formula NCR equals NCN minus R. So this will become 10C4, 11C5, 12C6, etc. Okay, but we will try to do it as it is. What term can be added with this so that it will be like that formula NCR plus NCR plus 1. Here this time we will add the term. Obviously we have to add 10. 10C what? We will add 10C5. If you add 10C5, you add these two, will get 11C6. But already 11C6, then we can't use that formula. So what you do is we add a 10C7, right? You add 10C7 with this. If you add 10C7 only, then so this formula can be used. 10C7 plus 10C6 plus these terms will be same, plus 20C6, and then subtract this added value, which is 10C7. Okay, yes. Now if you add 10C7 plus 10C6, that will become 11C7. So 11C7 can be added with 11C6. So this sum is 11C7. So that 11C7 can be added with the 11C6. Okay, so 20C6 minus 10C7. Okay, now if you add these two, it will become 12C7. So 12C7 can be added with the next term is 12C6. So you can keep adding this. So finally we will get, if you add up to this term, that will become 20C. This value is one more than that, 6, 7. So 6 here. So that means 7. 20C7 plus 20C6 minus 10C7. So that is again, so 21C7. 21C7 minus 10C7. So that's all. So that is the answer, right? So we have to adjust these terms so that it matches with our formula, right? NCR plus NCR plus 1. So we add this term and subtract that term, so that all these terms add up to this value, 21C7 minus 10C7. Okay, so that is the answer. Hereafter, all the results on the binomial coefficients will be like a series. This is the first example. This is the sum of all binomial coefficients, NC0 plus NC1 up to NCn. The sum of all binomial coefficients equals 2 to the power n, right? Now, let us take this simple example, 1 plus x to the power n, that is NC0 plus NC1x up to NCn x to the power n. Hereafter, mostly we will use this expansion only for our calculations, right? 1 plus x to the power n, so that is NC0, etc. Alright, yes. Now here, what you do, simple, you can substitute the value of x to be 1. So substitute the value of x to be 1. So then we'll get 1 plus 1, 2. So 2 to the power n, so that equals NC0 plus NC1 plus etc. up to NCn. So that's all. That is the result, right? The sum of all binomial coefficients equals 2 to the power n. That's it. Okay. For example, if you want to find the value of something like 5C0 plus 5C1 plus etc. up to 5C5, so we should be able to write the value directly. So it is of the same form. So the answer here is 2 to the power 5, or you can say it is 32. Okay, yes. So this is one result. You have to remember the sum of all binomial coefficients, that equals 2 to the power n. So that is one formula you have to know. Okay, yes. Now what if you substitute in place of x, you have minus 1 instead of 1. If you substitute minus 1, what will you get? So then 1 plus x, 1 minus 1, that is 0. So 0 equals, first term is NC0, next term will be minus NC1, next will be plus, right, because x is square, so NC2, etc. Last one is NCn. Okay, yes, that is minus or plus depending upon whether n is even or odd, right? For even value it will be plus, for odd value it is minus. You can write minus 1 to the power n if you want, but I'm just leaving as it is. So this is minus or plus depending upon even, odd or even. So this is also sum of all binomial coefficient, but alternate minus plus. Okay, then the value is 0. This is also result. Okay, you have to remember this also as a result. NC0 minus NC1 plus NC2 minus alternate plus minus, the value will be 0. If all the values are added, this sum is 2 to the power n. So this is also one result that you have to remember. Alright, so this is one result, sum of all binomial coefficients, sum of all NCR, so that equals 2 to the power n. Now here alternate plus minus, so that can be written as the summation minus 1 to the power r NCR, correct? So alternate plus minus, odd means minus, even means plus, so minus 1 to the power r NCR, that summation equals 0. Okay, so this is the next set of results about the binomial coefficients that you have to remember. Okay. Here also we have the sum of binomial coefficients, but not all the binomial coefficients. Okay, only even values for r, right? NC0, not NC1, NC2, and then NC4, NC6, etc. Only even values of r, right? We've already written this result, NC0 plus NC1 plus NC2, NC3 etc. Sum of all binomial coefficients, that equals 2 to the power n. So this is the formula we've derived. Now we've also written this formula, NC0 minus NC1 plus NC2 minus alternate minus plus, then you get 0. Okay, so this is the result we have derived. Okay, yes, now we can simply add or subtract. Okay, so if you add these two, minus plus NC1, that gets cancelled. This is 2 times NC0, 2 multiplied by NC0, and similarly 2 multiplied by NC2, only odd values, even values of R, right? So that's all. So that equals this. If you add, we get 2 to the power n. Okay, yes, so that's it. Now if you divide by 2, we'll get NC0 plus NC2, NC4, etc. Okay, so this equals 2 to the power n divided by 2. Okay, so that can be written as 2 to the power n minus 1. Okay, half of that value, that's it. So this is when we have only alternate terms. Okay, what if we subtract this instead of adding? So if you subtract it, you will get NC0 minus NC0, that gets cancelled. These terms get added, right? So like NC1 plus NC1, 2 times NC1 also, and we can also write this result NC1 plus NC3, NC5, etc. Only odd values. So that is also equal to, so what is that, what will you get if you subtract? Even if you subtract, you get the same value, right? 2 to the power n minus 0. So that is same as this one. So 2 to the power n minus 1. Alright. So both these can be remembered as results now. So only alternate values. Okay. So that is half of the total. Okay, so here also we have alternate values for odd values of this R. So that is also half of the total value, 2 to the power n. So 2 to the power n minus 1. Alright, so this is also result we have to remember, right? Sum of all binomial coefficients, that is 2 to the power n. Only alternate terms if you take, so that is half of the total, which is half of 2 to the power n, or 2 to the power n minus 1. Okay. Here also we have to find the sum of some binomial coefficients, right? NC0 plus NC4, NC8, etc. Okay, only every fourth term, right? 0, 4, 8, etc. Right? So not every second term. So that is alternate term. We have done half of that value. But here every fourth term, right? NC0 plus NC4 plus NC8, etc. Now we have to do some substitution. We have to substitute some value that repeats after an interval of length 4, right? So what is that? So we have to make use. So we've already substituted 1 and minus 1. We got some result. Now this time we have to substitute complex number, right? So we have to substitute this I or iota, right? So this we have to substitute x equals this I, okay, complex number, because this is a cyclic term, right? So if you raise power I squared, I cube, I to the power 4 is 1, then thereafter it is a repetition, right? It will repeat after every value of 4, right, of length 4. See, I is substituted. What will you get then? 1 plus I to the power n. So that equals, okay, so then NC0 plus NC1I plus NC2, okay, I squared, etc. Okay, now 1 plus I to the power n. Alright, so keep it as it is. So that equals NC0 plus NC1I. What is I squared? That is minus 1. So minus NC2. And next one is I cube. I cube is minus I. So minus NC3I. Next I to the power 4. That is NC4. I to the power 4 is 1 only. So that means NC4. So like this it will go on. Now from this we only take the real part. Okay. So this is real part. This is imaginary part. That is NC1I. So imaginary. So only take the real part. So if you compare the real parts of both the sides, what is the real part of right hand side? That is NC0 minus NC0 minus NC2 plus NC4, and next will be minus NC6, etc. So that is the real part of the right hand side. Only this NC0, then NC2, NC4, because these terms come with I. Now we have to find the real part of this. So how to find the real part of that? So real part of 1 plus I to the power n. Okay, we'll find that later. So this is the result we have derived now. But we've already got a result if you only take these values, right? Plus, all plus, right? NC0 plus NC2 plus NC4, NC6, all positive. That equals, see, this is the result which you have derived previously. That is 2 to the power n minus 1. Okay, all only odd value, even values of R, right? Only odd terms. So that is already known, 2 to the power n minus 1. Now you just add these two. Okay, if you add if you add these terms get cancelled, we'll get 2 times NC0 plus NC4 plus NC, next will be NC8, etc. So that equals, alright, so now 2 to the power n minus 1 plus real part of 1 plus I to the power n. Okay, that's all. If you divide by 2, we will get our required answer. But what is the value of this one, real part of 1 plus I to the power n? So we have to use some idea from the complex numbers. See, 1 plus I, power is there, right? So power is n. So we have to remove this power. For that, we have to use the de Moivre's theorem, right? If you remember, you have to write this complex number in polar form. Then we can use de Moivre's theorem. So then we can bring this power inside, right? So power will be multiplied with the argument. Say this is NC0 plus NC4, etc. That equals, so you divide by 2, you get 2 to the power n minus 1 plus 1 by 2, the real part of this. So real part of, okay, so this 1 plus I should be written in the polar form. What is polar form? R cos theta plus I sin theta. R is what? The modulus of the complex number, which is root 2. Cos theta plus I sin theta. Theta is what? Argument. That is tan theta is 1 by 1. Tan theta is 1. That means root 2 cos pi by 4 plus I sin pi by 4. Okay, so that's it. So this will give you 2 to the power n minus 1. Now see, real part of root 2 divided by 2. Okay, so that we can write it as, okay, so 1 divided by root 2 and then cos pi by 4, so power n. Okay, so to the power n. So this is 2 to the power n by 2. Okay, so 2 to the power, sorry, this is 2 to the power n by 2, right? So this is not 1 by root 2. So 2 to the power n by 2 totally. This 2 to the power half, the power n. 2 to the power n by 2 minus 1, right? 2 to the power n by 2 minus 1. Now here we have to use the de Moivre's theorem. Cos theta plus I sin theta to the power n. That can be written as cos n theta plus I sin n theta. Cos of n theta. What is n theta? N multiplied by pi by 4. I sin n pi by 4. Now we only need the real part here. So the real part is simply cos of n pi divided by 4. So that's also, that is the required answer, right? 2 to the power n minus 1 plus 2 to the power n by 2 minus 1 cos n pi by 4. So if you know the value of n, okay, then it is very easy. So we can remove this. So whatever the value of n, we can find this value, cos of that value, and that will give you our required answer, right? But generally for any value of n, so this is the answer, 2 to the power n minus 1 minus 2 to the power n by 2 minus 1 cos of n pi by 4. That need not be remembered as a formula. This is not a formula. But for every odd values, that you have to remember 2 to the power n minus 1. For every fourth value, okay, you can do these steps. Okay, this is not a formula. You need not remember it as a formula, but at least know how to do this. Okay. Here also we have to find the sum of some binomial coefficients. Every third term here, 0, 3, 6, etc. Right? So for every fourth term, we've used this substitution x equal to I, because I repeats after the power which is a multiple of 4. Right? I to the power 4 is 1. Similarly, here we have to use, obviously, right, cube. So which number cube? That equal to 1. So again, complex number substitution only. So substitute x equal to omega. Right, so omega cube root of unity, because we know that omega cube is 1, so it repeats after the power of 3. So x equal to omega, right? So if you do the substitution in the same expression, we get 1 plus omega to the power n. So that equals nc0 plus nc1 omega plus nc2 omega square plus nc3 omega cube, etc. Okay, so this is a simple substitution, cube root of unity. We also substitute omega square, right, which is also cube root of unity, right? So omega square to the power n. So we substitute x equal to omega square also. So 1 plus omega square to the power n. So that equals nc0 plus nc1 omega square plus nc2 omega to the power 4, right? So nc2 omega to the power 4 is same as omega only, right? Omega to the power 4 is omega cube multiplied by omega, that is omega. And nc3 omega power 6, so that is omega, okay, let me write as t, but this is 1 only. Omega to the power 6 is 1, omega cube is also 1. So all the powers which are multiples of 3, it is 1. So now you substitute x equal to 1, right? Or the result which you know already, say 2 to the power n, that equals nc0 plus nc1 plus nc2 plus nc3 etc. Okay, so this result we are already familiar with. See, we've simply substituted all the cube roots of unity. What are the cube roots of unity? 1, omega and omega square, right? So these are the cube roots of unity. So we substituted all these values and we got these three results. What you do? Simply add. So if you add all these terms, okay, so what do you get here? This as it is 1 plus omega to the power n, 1 plus omega square to the power n plus 2 to the power n equals nc0, nc0, nc0. That becomes 3 times nc0. Okay, 3 multiplied by nc0. What is this sum? nc1, nc1, n, 1 plus omega square. Sum of all cube roots of unity. That is 0, right? That means, so this term becomes 0. nc1 multiplied by 0. So this term is gone. What about this term? Again nc2 multiplied by omega square plus omega plus 1. So again 0. So this term is also cancelled. Now what is the next term? That is nc3. Because omega cube is 1. Omega power 6, that is also 1. 1. So 3 times nc3. So that means 3 you can take out. So 3 times nc0. Similarly, the next term nc4. So that will become 0. So only multiples of 3 you will have, right? So that's all. This is what we need. So this gives you our required expression nc0 plus nc3 plus nc6, etc. So that equals, you can divide this by 3. Before that, 1 plus omega can be written up 1 plus omega square, that is 0. That means 1 plus omega is minus omega square. So that is minus omega square to the power n. And similarly, this is 1 plus omega square, that is minus omega. So minus omega to the power n plus 2 to the power n, the whole thing divided by 3. So that's all. So this is the sum of all binomial coefficients, multiples of 3, right? So that has value, this one. If you know the particular value of n, we can substitute and simplify this. So this will be a real number, even though omega is an imaginary number. Whatever is the value of n, if you do the simplification, it will become a real number, right? Because we don't know what the value of n is. Suppose n is a multiple of 3, it will give you some result. If n is not a multiple of 3, it may be different. So it depends on the value of n. Now we don't know what n is, so this is the result. Okay, so that's all. So that is the sum of these binomial coefficients. Okay. Here also we need to find the sum of every third term, 1, 4, 7, etc. Right? But it does not start from the first term. Unlike the last question where we had nc0, nc3, nc6, all multiples of 3. Here it starts from the second term, which is nc1. But the difference is 3, 1, 4, 7. If the difference is 3, we have to use the same idea, omega, but with some small changes here. So let us use the same expansion, 1 plus x to the power n equals nc0 plus nc1x plus etc. But the value of n is also known here, so that is 25. So that means there in that expansion we have to substitute x1, just like the last question. Substitute x1, you will get 1 plus 1, which is 2 to the power n, will be 25. That equals nc0, 25 c0, 25 c1 plus 25 c2. Okay, so many more terms. Okay, now you substitute x omega. Okay, if you substitute omega, we get 1 plus omega to the power 25. That equals 25 c0 plus 25 c1 omega plus 25 c2 omega square, etc. Okay, yes. Now then we also have to substitute x equal to omega square, right? So x omega square. So then we will get 1 plus omega square to the power 25 equals 25 c0 plus 25 c1 omega square plus 25 c2 omega to the power 4, which is omega only. So etc. Okay, now what did we do there? We just added. If you add, these terms get added and then other terms get cancelled. 25 c1 plus omega cancelled, then we will get only 25 c3. So 0, 3, those are the terms which are non-zero. So but we will not do that here because we want this term. We want this term. If you directly add it, only this term will remain, this term will get cancelled, but we want to cancel the first terms. Only this term should be there and then this term should also be cancelled. What we do is, you don't directly add this. What we do, you have to multiply, right? You have to multiply this by omega square. Why do you multiply by omega square? Only then omega multiplied by omega square will become omega cube, which is 1. Okay, we want this value to be constant. Okay, so if you add, it should not become 0. So multiply the whole term by omega square. okay, because it is omega. Similarly, multiply this term by omega, because 25c1 omega square is there. If you multiply omega, it will become omega cube, which is 1. So multiply this term by omega square. So if you multiply by omega square, this is omega square multiplied by 1 plus omega to the power 25. That equals, so this will become 25c0 omega square plus 25c1, this will become omega cube, that is 1, plus 25c2, this is multiplied by omega square, that means it will become omega plus etc. So this is what we get after multiplying omega. Similarly, this term you multiply by omega. So omega multiplied by 1 plus omega to the power 25 equals 25c0 omega plus 25c1, this multiplied by omega, that will become omega cube. Okay, so 25c2, this multiplied by omega, so it will become omega square, etc. Okay, now you add these terms. Okay, if you add, you will get our required answer. See, we are adding these three, this and this. Okay, 25c0 and the next 25c0 omega square and 25c0 omega. So 25c0, 1 plus omega, so that will become 0. So that will first term become 0. So if you add this, we will get 2 to the power 25 plus this term is omega square multiplied by 1 plus omega to the power 25 plus, so this is omega 1 plus omega square to the power 25. So if you do this addition here, so first terms get cancelled, 25c0, 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 1 plus omega square, that becomes 0. Second term is what? 25c0, next again 25c1 and next also 25c1, 3 times 25c1. So 3 multiplied by 25c1. And similarly, the next term will become 0, right? Because 25c2, next to 25c2 omega, next 25c2 omega square, 1 plus omega square, that becomes 0. So next term will be 25c4 only. Okay, so the next term will also become 0. Okay, so we can, every third term only will be left. So that's all. So this is our required answer, right? So we have to do this division, divide by 3. So this implies 25c1 plus 25c4, etc. So that equals this value, 2 to the power 25. And the next term, omega square. But what is 1 plus omega? So that is minus omega square. So that if you simplify, so it is plus omega square. This is minus omega square to the power 25. Similarly, this is omega multiplied by, this is 1 plus omega square. That is minus omega multiplied by 25. The whole thing divided by 3. Okay, so if you do the simplification, so we'll get 2 to the power 25, and then this is minus omega to the power 50. Okay, omega to the power 50 here square, so omega to the power 52, so that is omega only, right? Omega to the power 51, that is 1, because 51 is a multiple of 3, but here omega to the power 52, so that means it is simply omega, and then this is minus again, so this is omega to the power 25 plus 1, that is 26. Omega to the power 26 is same as omega square. Alright, because 24 plus 2 is 26, omega to the power 24 is 1, so omega square. Now if you take this minus out, so it will become plus, again omega plus omega square is minus 1, right? 1 plus omega square is 0, omega plus omega square is minus 1, so we will get 2 to the power 25 plus 1 divided by 3. So that's all. So that is the required answer. Okay, yes. Now see, the moment you get every third term, right? So we want to find every third term, the sum of these terms, then you have to use omega. But then you directly, if you add, you will get the sum of first terms, and then third term, and then sixth term, first term, third term, sixth term, etc. But if you have to make some small changes, you have to do that, right? If you directly add it, you will get only this term 25c0, but we want to start with the second term 25c1. So we've just multiplied by omega square here, multiply omega, then you add up, we get our required answer. Okay, yes. Here the binomial coefficients are multiplied by the natural numbers, right? The first term is multiplied by 1, second term multiplied by 2, third term multiplied by 3, etc. Right? 1 multiplied by nc1, 2 times nc2, etc. Alright, so we have to find this sum. If these numbers are not there, 1, 2, 3, so we have the direct formula, sum of all binomial coefficients. So this is the formula we are already familiar with, right? Sum of all NCR, right? The sigma r is from 0 to n, NCR, that equals 2 to the power n. This formula we are already familiar with, but what is given here is different, right? So here this sum actually is summation r multiplied by NCR. Okay, r multiplied by NCR, r is from 1 to n. Alright, 1 multiplied by NC1, 2 NC2, 3 NC3, etc. Okay, so this r is a problem. If this r was not there, then we have the direct formula. So how to remove this r? So we are going to do this by two methods. So the first method is r is from 1 to n. We have written one formula, if you remember. NCR can be written as n divided by r multiplied by n minus 1 CR minus 1. So this is one formula. Alright, NCR is written as n by r, n minus 1 CR minus 1. So this r is cancelled now. This n is a constant, right? So the summation is over r only. So we can take this n out. So n multiplied by the summation r is from 1 to n, n minus 1 CR minus 1. Now we have removed this r. This sum we know, right? This is sum of all binomial coefficients. So directly we can write the answer. Or if you want, you can write the expansion. So substitute r value 1. We get n minus 1 C0. Next n minus 1 C1. Next n minus 1 CR is 3. So 3, 2 plus etc. Okay. This is what? This is NC0 plus NC1 plus NC2, that is 2 to the power n. But in place of n, we have n minus 1. That means the formula here is n multiplied by 2 to the power n minus 1. So that's all. So that is the answer. Okay, n multiplied by 2 to the power n minus 1. That is the sum of a series of the form r multiplied by NCR. Okay, so that is the answer. Now, we'll also do this question by another method, right? Both the methods are important. Not just the result, but the methods are also important, right? So here we know that 1 plus x to the power n, that is NC0 plus NC1x plus NC2x squared plus etc. So this we know already. Now here we substituted x value 1. Then we got the result NC0 plus NC1 plus NC2, that equals 2 to the power n. But here we can't directly substitute n because each term should be multiplied. See, this term is multiplied by 1, no problem. This term is multiplied by 2. Next term is multiplied by 3. What we have to do is, we have to use some basic differentiation. So differentiating this expression, alright, what do you get? So from physics you must have learned some basics of differentiation, right? Simple function like x square, so that has derivative 2x, or x cube, derivative is 3x square, x to the power n in general has derivative n, x to the power n minus 1. We are just using the basic differentiation. If you differentiate this, so we'll get n 1 plus x to the power n minus 1, that equals this derivative. This is 0, right? First term is 0 because constant, and nc1 x derivative is 1 plus nc2 x square derivative is 2x. Next term is x cube derivative is 3x square, so 3 nc3 x square etc. Okay, yes, so this is the derivative of the terms. Okay, now substitute x1. So if you substitute the value of x1 here, we'll get n multiplied by 2 to the power n minus 1, that equals, so this is nc1 plus this is 2 times nc2, x is 1, so 3 times nc3. Okay, so that's also, this is the result we are supposed to derive, right? That's all, same result here. So n 2 to the power n minus 1, that is 1 multiplied by nc1, 2 times nc2, 3 times nc3, etc. Okay, so that is the result. So this is also one of the methods of deriving this result. So this method is also important. Okay, yes. Now we can also write one more thing. If you substitute x value, say minus 1, if you substitute x minus 1, so here what will you get? 0. We get 0 equals, so that is nc1 minus 2 nc2 plus 3 nc3. See, if alternate minus plus, even this becomes 0, right? So even the basic formula nc0 minus nc1 plus nc2, that formula becomes 0, right? Because alternate plus minus, even this formula becomes 0 when it is alternate plus minus. If all the terms are added, right, plus, then you will get the sum n 2 to the power n minus 1. But if there is alternate plus minus, even this series becomes a 0. Okay, so generally, so this is the formula. This is a formula that you have to remember. So the next formula in our list, so summation of r and cr, that equals 2 to the power n minus 1 multiplied by n. Alright, and here also, if there is alternate plus 1, that means minus 1 to the power r NCR, so that value is 0. Okay, yes, so this is the next series that you have to remember. All right, but the method is also important. So here we eliminated this r by using the formula, and then we found the sum of the known series. There we use the differentiation to find the answer. All right, the method is also important along with just the formula. Okay, formula anyway you have to remember, and the method is also important. Okay. Here also the binomial coefficients NC0, NC1, NC2, etc. are multiplied by some numbers. But in the last question, those numbers were just natural numbers, right? 1, 2, 3, etc. But here, the numbers multiplied are not just natural numbers, but they form a pattern, right? 2, 5, and 8, etc. But these numbers form a pattern. So what is that? These numbers are in arithmetic progression. So this is a combination of an arithmetic progression and the binomial coefficient, right? So this type of question can be done by this particular method, a combination of binomial coefficients with an arithmetic progression. So what do you do? We use that summation method, that is the easiest method. You can use differentiation method and all, but the easiest method is, because we have derived the formula, we don't go back to the differentiation again. We will directly use that sigma, right, summation method. Yes. Now what do you do? We write the general term. Okay, what is the general term? So that is 2 NC0 plus 5 NC1 plus 8 NC2, etc. Okay, so this is the arithmetic progression 2, 5, 8. Okay, this is an AP. So the AP is here 2, 5, 8. Alright, so next will be 11, etc. Okay, yes. Now write the general term. General term means what? Nth term or rth term, right? Rth term. And here NC0, NC1, NC2, generally NCR. But here we have to write it. But you don't consider the first term, you start from the second term, because that is when R is 0, right? So we will start from the first term, okay? So these terms, let us consider these terms. So which means, let us consider the first term of AP to be 5 only. 5, 8, 11, etc. What is the rth term of an AP? That is first term, A plus n minus 1, r minus 1 here. R minus 1 multiplied by D. D is 3. So that means it is 3R plus 2. So that is the rth term of the arithmetic progression. Okay, we have started from the second term only, because we are going to substitute R0 only. If we substitute R0, we will get 2. That is the first term. If R is 1, we will get 3 plus 2, 5, etc. So that means the given expression can be written as summation of 3R plus 2 multiplied by NCR. So we can verify this. R is from 0 to n. Okay, see, you can easily verify this. Substitute R0. What do you get? 2 multiplied by NC0. That is the first term. R is 1. We'll get 5 multiplied by NC1. Next, R is 2. 8 NC2, etc. Okay, this is what is given. So we have written this expression in this short form. That's all. Now this is summation, addition. So addition can be separated, right? Because addition here. So we can separate this sigma over this addition. So 3R multiplied by NCR, that is first term. 2 multiplied by NCR, that is second term. So this is summation. So we can write it as 3 multiplied by sum of R NCR plus 2 multiplied by the summation NCR, right? So where R is from 0 to n, R is from 0 to n. Alright, we can split it, because addition only. Addition we can split it, right? Like this one. So 3R NCR, 3R NCR, that is the first term. Similarly 2 NCR, that is summation is split into two parts. Now we have formula for each term. What is sum of all NCR? That is sum of all binomial coefficients 2 to the power n minus 2 to the power n. So that is okay. So similarly we have also derived formula for this R NCR summation. So that is n multiplied by 2 to the power n minus 1 plus 2. This is sum of all NCR, that is 2 to the power n. So that's also, that is our required answer. That's it. Okay, but you can take out some common factor, right? So we can take 2 to the power n minus 1 out. We'll get 3n. 2 to the power n minus 1 is taken out. So 3n plus 4. So this is the sum of all these terms. So just write the general term. So once general term is written, the rth term, then you apply the summation here, right? Summation, then you can separate it and find. We have formula for each of these terms, right? R NCR as a formula, and then see, but the formula R NCR starts with the 1. R is from 1 to n, R NCR. But now we have started with 0 to n. But does it make a difference? Anyway, if you substitute 0, you will get 0 into something, right? So that is 0 only. So whether it starts from 0 or 1, it doesn't make a difference here. Okay, sometimes it makes a difference, but for this example, even if we start from 0, anyway we substitute 0, we are getting 0, so no problem, 0 or 1 doesn't matter here. Okay, so that is the answer, 2 to the power n minus 1, 3n plus 4. Okay. Here also we have binomial coefficients multiplied by some numbers 3, 6, 12. So these numbers form a GP, right? Geometric progression, not arithmetic progression. So this is very simple, no need of any formula. So 3, 6, 12, these numbers form a GP and binomial terms combination. Alright, how to do this? Just like the last one, we write the general term. So here we have 3 multiplied by NC1, then 6 multiplied by NC2, then 12 multiplied by NC3. Now how to write the general term? Here it starts with this one NC1 only. So this is the first term, 3, 6, 12. So these numbers form a GP, right? 3, 6, 12. So what is the general term of a GP? So that is 3a multiplied by r. R is 2 here, right? 2 to the power n minus 1. Okay, n minus 1 here is r minus 1. So that's all. So this is the general term of only that GP. Now we have to write we have to write this NCR also. So that means the given expression can be written as 3 multiplied by 2 to the power r minus 1 multiplied by NCR. Okay, so substitute and verify, right? Summation r is from 1 to n. Yes. Now if you substitute r1, we'll get 3 multiplied by NC1. That is the first term. Now r is 2. 3 times 2, that is 6 multiplied by NC2, etc. Alright, so this is the summation form of the given expression. Now we have to find this sum. How to find it? So we can write it as 3, we can take out. Alright, we can directly substitute. If you want, you can directly substitute the value of r1, etc. Directly also we can do. So first, if you substitute r as 1, we'll get NC1 2 to the power 0. Okay, plus NC2 2 to the power 1 plus NC3 2 square, etc. Alright, yes. Now this is not in the proper form. What you do, you divide by 2 and multiply by 2. So that is NC1 2 plus NC2 2 square plus NC3 2 cube. See, this only is in the known form. What is this? NC1 2, NC2 2 square, NC3 2 cube. This is the binomial expansion of, see, this is 3 by 2 multiplied by this is 1 plus 2 to the power n. Alright, so what is the formula 1 plus 2 to the power n? It is like 1 plus x to the power n, but x is 2 here. Like first term is NC0, that term is missing. Okay, finally we can subtract that. So first term is NC0, next term is NC1 2, NC2 2 square, NC3 2 cube. That's what we have. So this is simply the expansion of this one, 1 plus 2 to the power n. But first term is missing, NC0, that you have to add and subtract. So minus NC0. We have added and subtracted. Okay, that's all. That is the answer. So this is same as 3 by 2, 3 to the power n minus 1. So that's all. So this is the answer, right? If a combination of a geometric progression and the binomial coefficients are given, so we have to simply do this method. No need of any other formula. We only use this formula. We use the summation. Write the general term, apply the summation. It will be of the form 1 plus x to the power n for some value of n. Okay, some value of x. So that will give you our required answer, 3 to the power n minus 1 multiplied by 3 by 2. Okay. We've derived the formula for summation r NCR, right? 1 NC1 plus 2 NC2, etc. But here it is 1 square NC1, 2 square NC2. It is of the form r square NCR, right? So how will you derive that? So this series is of the form summation r square multiplied by NCR, right? 1 square NC1, 2 square NC2, etc. Alright, how to do that? So we can do it by two methods, just like the other formula here also. So we have to remove this r, first method, and we can also use by the differentiation method. So let us remove this r. How to remove this r? So we can use the same idea here. So r square NCR can be written as n by r multiplied by n minus 1 c r minus 1. So 1 r can be cancelled. Okay, so this n can be written here, summation. This is r multiplied by n. So then this r is still there, right? How will you cancel this r? If you use the formula again here, the same formula, if you use again, you will get n minus 1 divided by r minus 1 and n minus 2 c r minus 2. But r minus 1, that will not cancel with this. So what we do is, we will write this r as r minus 1 plus 1. subtract and add 1. So n minus 1 c r minus 1. We subtract and add 1 because we want to cancel this r minus 1. So that can be written as summation. We can split into two parts. R minus 1 n minus 1 c r minus 1, that is one term, plus next term is 1 multiplied by this one. So n minus 1 c r minus 1. Okay, so that's all. So this r minus 1 can be cancelled now. So by using the same formula, so this is r minus 1. Now n minus 1 c r minus 1 can be written as n minus 1 divided by r minus 1. Okay, n minus 1 by r minus 1 multiplied by n minus 2 c r minus 2. Okay, 1 less than that. Same formula we use here also. So that equal plus, yeah, that is n minus 1 c r minus 1 as it is. Okay, yes, this time this r minus 1 gets cancelled. Okay, now this summation can be split into two parts. So that is n multiplied by n minus 1 and summation, what is that? This is n minus 2 c r minus 2 plus this is n multiplied by sigma n minus 1 c r minus 1. So that's all. So there's no r here, only this binomial coefficient. Okay, here also. So we can use the same sum of all binomial coefficients. So here r is from 2 to n. Remember, not from 1, r is from 2 to n. We can't substitute r 1, right? We have to start from 2 because this value cannot be negative. So we start with 2. So here r is from 1 to n. So what will you get? N multiplied by n minus 1. So if you want to write the value of the each term, so first r is 2, we'll get n minus 2 c0, next n minus 2 c1, etc. Similarly here, if you substitute the value of r1, we'll get n minus 1 c0 plus n minus 1 c1, etc. So that is sum of all binomial coefficients, but in place of n we have n minus 2, here n minus 1, so we'll get n multiplied by n minus 1, so that is 2 to the power n minus 2 here, plus here n multiplied by, that is 2 to the power n minus 1 here. So n multiplied by 2 to the power n minus 1. So that's it. So we can take out the common factor, which is n multiplied by 2 to the power n minus 2 is taken out. So we'll get n. So we'll get n minus 1 here plus 2. So that's also, that is our required answer. n plus 1 multiplied by 2 to the power n minus 2. So that's all. So this is the sum of square of this value, right? R square multiplied by the binomial coefficient, that is formula n plus 1, 2 to the power n minus 2. Okay, yes. Now first our aim is to remove this r square. How to remove? First r can be removed using the same idea that we used in the other formula, but here the second r can be removed if you have to do this, then you have to do this one, right? Subtract and add 1, again using the same formula. So we remove this multiple, then we can use sum of binomial coefficients to get the answer. Now we can also do this question by the other method, that is differentiation. Okay, so this is the alternative method of deriving the same formula. So we have 1 plus x to the power n, so that is nc0 plus nc1x plus nc2x squared, etc. So this is the formula we know. Let us do the differentiation. Okay, if you do the differentiation here, so find the derivative. So n multiplied by 1 plus x to the power n minus 1, so this is 0. So nc1 plus 2nc2x. Okay, next will be 3nc3 x square, etc. Okay, so just differentiation. Okay, done. Now you can substitute the x value 1 to get that previous result, but now we want 2 square. We want 3 square here. How to get this 3 square here? If you again differentiate, what will you get? 3 multiplied by 2. Here 2 multiplied by 1. So, but we want 3 multiplied by 3. 2 multiplied by 2. What do you do? Multiply the whole equation, right? So multiply by x. If you multiply the whole equation by x, you get x square here. That if you differentiate, you will get 2 times 2. Okay, 3. If you x cube differentiation is 3x square, 3 multiplied by 3. So the whole equation is multiplied by x. So we'll get nx 1 plus x n minus 1, that equals nc1x plus 2 nc2 x square, okay, etc. That is x cube. Now again differentiate. If you do the differentiation again, then you will get 2 multiplied by 2, 3 multiplied by 3, etc. Okay, but to do the differentiation of this, you have to know the product rule. So product rule, one is a function, the other one is function, the two functions multiplied. So to find the derivative, this function multiplied by derivative of this, and this function multiplied by derivative of this. Alright, so nx multiplied by the derivative of this, so that is n minus 1 plus x to the power n minus 2 plus this multiplied by derivative of x. Derivative of x is 1 only, so that is n multiplied by 1 plus x to the power n minus 1 as it is. This is the derivative of the left hand side, so that equals, similarly right hand side, that is nc1 multiplied by 2 multiplied by 2, that is 2 square nc2. Similarly next term will be 3 square nc3, etc. Okay, so that's all. Now you substitute the value of x 1 here, so substitute 1 here, we'll get our required answer nc1, 2 square nc2, 3 square nc3, etc. Okay, so if you substitute x1, what do you get? n minus 1, 2 to the power n minus 2 plus here also n 2 to the power n minus 1, that equals nc1 plus 2 square nc2 plus etc. So that's what we want, right? So this is the same result here. So we'll get, if you simplify this, you will get our required answer. So if you can take n multiplied by 2 to the power n minus 2 out, so we'll get n minus 2 plus 2, that is n plus 1. So that equals our required answer nc1 2 square nc2 plus etc. Okay, so that's also, that is the required answer. So it can be derived by these two methods. Okay, so one method is by removing this r square using this formula, and then we can also use differentiation to find the same answer. Alright, yes. So that is also a formula you have to remember, summation r square NCR, right? Summation r square NCR is equal to this one, right? n plus 1, 2 to the power n minus 2. If you remember this also, right, that can be directly used in questions. Instead of doing all these methods, you can directly use it in questions if you just remember this formula. Okay, so n plus 1, 2 to the power n minus 2, that is the value of summation r square NCR. Okay, yep. This time we have the numbers in the denominator, right? So nc0 divided by 1, nc1 divided by 2, nc2 divided by 3, etc. Numbers are multiplied, we use differentiation method. But here we have to use integration, right? Yes, the integration of x cube is what? X to the power 4 divided by 4. The number will come in the denominator. Obviously, we have to use integration, right? See, we can also try this method. See, this is summation, okay, NCR divided by r plus 1. Okay, so this is the general form, right? R is from 0 to n. So if you substitute R0, we'll get NC0 divided by 1, NC1 divided by 2, etc. So it is written in this form. Okay, now what you do? So we can also try like this. You divide by n plus 1. If you divide, you can multiply by n plus 1. So n plus 1 divided by r plus 1, NCR. So this is that reverse formula, right? So we know that NCR equals n by r, n minus 1 CR minus 1. Now this can be included with this. So this can be written as summation of n plus 1 n. So it will become n plus 1 CR plus 1. So that only is written like this, right? n plus 1 CR plus 1 can be written as what? n plus 1 divided by r plus 1 multiplied by 1 less than that is n CR. Okay, so this is one way to do this question. So 1 divided by n plus 1. Okay, so where r is from 0 to n. Okay, now directly substitute, that is sum of all binomial coefficients, right? So n plus 1. So if you substitute r0, we will get n plus 1 c1 plus n plus 1 c2, etc. Okay, last n plus 1 c n plus 1. Okay, so this is sum of all binomial coefficients. So you know the value of this, 1 divided by n plus 1. So that is 2 to the power n plus 1. Okay, but minus 1 because first term is missing here. What is the first term? N plus 1 C0. It starts from 1, 1, 2, 3. First term is NC0, that is missing. So n plus 1 C0, that is 1, right? That is added and subtracted. So that's all. So this is the answer, 2 to the power n plus 1 minus 1 divided by n plus 1. So that is the value of the given expression using one of the methods. If you try the other method, that is integration, right? So that is an alternative method. Okay, yes, so we know the basic expansion 1 plus x to the power n, that is nc0 plus nc1x plus nc2x squared, etc. Okay, now what you do, we have to do integration, okay, to get this number in the denominator. Okay, let us do the integration, but with the limit 0 to 1, because anyway finally we are going to substitute 1 only, right? So definite integral, right? Substitute 0 to 1. Okay, first let us do the integration of this. So if you do the integration of this, this is 1 plus x to the power n plus 1 divided by n plus 1. The limit is there, so we have to substitute the lower limit and upper limit. Anyway, so that is nc0, which has integration nc0x plus nc1 x square divided by 2. Okay, etc. Many more terms are there. So now we substitute the limits 0 to 1. So let us substitute this upper limit 1. If we substitute 1, we get 2 to the power n plus 1. Lower limit is 0, so 1 only. So minus 1 divided by n plus 1. So this is the value. Now you substitute there also upper limit, that is nc0 plus nc1 divided by 2. Similarly, next term will be nc2 divided by 3, etc. And if we substitute lower limit 0, all the terms will become 0. So that's all. So that is what we want right here. 2 to the power n plus 1 minus 1 divided by n plus 1. That is the value of this expression. Okay, yes. So that's it. So remember that we have to use integration method. But this need not be remembered as a formula. Okay, because we don't know what number comes in the denominator. Sometimes these numbers may be different. So you need not remember this as a formula, unlike the other ones, right? Multiplication, that you have to remember, but this at least know the method. So we can either do by this integration method. Mostly we use this integration method only. So this method we will not do when there is a denominator. Okay, we will avoid this method. We will try to do by the integration method to get answer to the questions of this type when the number is in the denominator. Okay, so that's all. So this is the answer to the question. Here also we divide by some numbers, right? 5, 7, 9. But unlike the last one, here the numbers are not consecutive. So there we had 1, 2, 3, etc. Right? But here we have 5, 7, 9. But these numbers are in AP, right? 5, 7, 9. That means this is a harmonic progression because it is in the denominator. So harmonic progression combined with the binomial terms, right? So it is a combination of the binomial coefficients and a harmonic progression. How will you do? So when you have denominator like this, you have to do integration method only, alright? But we cannot directly integrate it. Let us see. See, we have this expansion 1 plus x to the power n, that is nc0 plus nc1x plus nc2x square, etc. Okay, if you directly integrate it, you will get x cube divided by 3. That means nc2 divided by 3. But that is not what is given, right? It is like 5, 7, 9, right? So that means you don't get 7. Alright. So what you do is, when there is a difference, what is the D, right? The common difference of this AP in the denominator, that is 5, 7, 9. That means 2 is the common difference. That means you have to replace this x by x square. Okay, when the difference of the AP is 2, replace x by x square. If the common difference is 5, then replace x by x to the power 5. Okay, so then only you will get that difference here. See, if you do that, we will get 1 plus x square to the power n. That is nc0 plus nc1 x square plus nc2 x to the power x to the power 4. Okay, etc. Now we will have the difference 2, right? 2 and then 4 and then 6, so the difference is 2. But even if you differentiate this, you will not get our required answer. X to the power 5 divided by 5 you will get. But we want nc2 divided by 7 we want. Okay, so what you do is, now you multiply this by x square. When you multiply this by x square, what will happen? X to the power 6. If you integrate it, x power 7 divided by 7, you will get the required answer. So the whole thing is multiplied by x square. So x square multiplied by 1 plus x square to the power n. So that equals nc0 x square plus nc1 x to the 4 plus nc2 6. So that's it. Now we have to do the integration, right? So as usual, so let us do the integration from 0 to 1. Okay, so that's all. So we will get so what is the integration of this? You write as it is, okay, because the answer is given in terms of integration only. You don't need to do the integration of this complicated term. X square 1 plus x square to the power n dx. So that is the integration of left hand side. So if you do the integration of the right hand side, you get nc0 x cube divided by 3. Okay, nc0 x cube divided by 3 plus nc1 x to the power 5 divided by 5 plus etc. Okay, so we have to substitute the limits 0 to 1. So that equals, if we substitute 1, we'll get nc0 divided by 3 plus nc1 divided by 5 plus nc2 divided by, next one will be 7, okay, etc. So if you substitute 0, we'll get 0 anyway. So that's what, that is our required answer. Okay, yes. Now, but that is not what is given in the question. So this term was not there, right? So in the question, it starts from nc1 only, nc1 divided by 5, nc2 divided by 7, etc. So that means this term you have to subtract it. So this implies our required term, which is nc1 divided by 5 plus nc2 divided by 7, etc. So that is written as this integration. Okay, integration 0 to 1 x square 1 plus x square d, to the power n dx. From that you subtract this term, right? So nc0 divided by 3. So that is just 1 by 3, correct? No? So this value is just 1 by 3 that you can substitute. That means this integration minus 1 by 3, that is our required answer. Alright, so just remember, so if a harmonic progression is combined with binomial coefficients, so what we have to do is integration, but this is the basic expansion. There you replace x by x to the power whatever the difference is, right? The difference of the common difference of the AP in the denominator. So that you have to replace x by x to the power that common difference. Okay, yes. But still you have to multiply by something, so that multiply by this x or x square something, so that it matches with what is asked in the question, right? So x to the power 4, so we want 7 in the denominator, so we make it x to the power 6 by multiplying x square. Okay, yes. Now, so that is the method we use to do questions of this type when the numbers are in the denominator. Okay. This is also done by integration because we have denominators, but the numbers in the denominator are not simple numbers but multiplication of two numbers, like 2 times 1, 3 times 2, etc. right? Maybe you have to do integration 2 times. Okay, let us see. So first one, see we have this basic expansion 1 plus x to the power n. So that is nc0 plus nc1x plus nc2x square plus etc. Okay, yes. Now let us do the integration. So if you do the integration, we'll get the denominator x cubed divided by 3. So 3 will come in the denominator. See, x square divided by 2. But we want 2 multiplied by 3. So one more time you have to do integration. So first time what you do, you integrate from 0 to not 1, 0 to x only. We want to keep it a variable only, right? So if you do integration from 0 to 1, that will become constant. Then what is the point in integrating again? So integration from 0 to x. So that means this integration is 1 plus x to the power n plus 1 divided by n plus 1. Now this limit is from 0 to x. So this integration is nc0x plus nc1x square, sorry, nc1x square by 2 plus nc2x cube divided by 3. Now the limit is from 0 to x. Now if you substitute this upper limit x, we'll get the same thing. So 1 plus x to the power n plus 1. If you substitute the lower limit 0, we'll get 1. 1 divided by n plus 1. Okay, yes. So that equals, so if you substitute this upper limit, so you will get the same thing, right? nc0x plus nc1x square by 2 and nc2x cube divided by 3 plus etc. Lower limit will give you 0 anyway. Now what you do, you again do the integration. Why do you do integration again? Because if you do the integration, x cube divided by 3, already 2 multiplied by 3. So x to the power 4 divided by 4, 3 times 4. So that's what we want, right? So that means again do the integration from 0 to this time not 1 but 2. See, given expression is of the form, see nc1 2 cube and 2 to the power 4, nc2 square. That means x value is 1. Okay, the terms are x square, x cube, x to the power 4, but 2 square, 2 cube, 2 to the power 4, which means x becomes 2, right? That means you have to integrate from 0 to 2. Okay, if that 2 square, 2 cube are not there, so we can just integrate from 0 to 1. That's what we did in the previous cases, right? But here 0 to 2. So let us do the integration of this again. So if you do the integration of this, this is 1 plus x, okay, to the power n plus 2 divided by n plus 2. Okay, but already n plus 1 is there, n plus 1 multiplied by n plus 2 minus, this integration is just x, right? X divided by n plus 1. Okay, so this integration from 0 to 2. Now similarly that one, nc0 x square divided by 2 plus nc1 x cube divided by 3, already 2 is there, 2 times 3, plus this is nc2 x to the power 4 divided by 3 multiplied by 4, so etc. So that is from 0 to 2. Okay, let us substitute the limit. So substitute 2 here. So if we substitute 2, we'll get 2 to the power n plus 2 divided by, if we substitute 2, we'll get 3. Okay, so 3 to the power n plus 2 divided by n plus 1, n plus 2 minus x is 2. So 2 divided by n plus 2 minus, if you substitute 0, this will become 0. If you substitute 0 here, so 1 divided by n plus 1, n plus 2. That equals, so if you substitute 2 here, nc0 divided by 2 multiplied by 2 square, nc1 divided by 2 times 3 multiplied by 2 cube. Okay, actually that is what we want. Okay, this is what is asked in the question. So that means this is our required answer. Okay, so this is the answer. But you can simplify this further, right? So this can be simplified further. This is the answer, but it has to be simplified further, right? So how to do that? Take LCM n plus 1, n plus 2. If you do the LCM, that is n plus 1 multiplied by n plus 2. So we'll get 3 to the power n plus 1, n plus 2 minus 1 minus 2 multiplied by n plus 2. Okay, so that if you simplify further, 3 to the power n plus 2, so minus 2n. This is minus 2n, minus 1, minus 4. So minus 5 divided by n plus 1 multiplied by n plus 2. Okay, so that's all. So this is the required answer. Okay, so that's all. So integration. The moment you get denominator, you have to do integration. But here we have to do 2 times integration because these numbers are like multiples of 2 numbers. Okay, so we integrate 2 times to get the required answer. Okay.